Imagine waking up tomorrow morning and stepping outside, coffee in hand, expecting to see the same familiar sky you've always known. The pale blue dome above you, maybe a few clouds drifting lazily across the horizon, the sun climbing its usual path. But instead, you look up and your coffee slips from your fingers. Stretched across the entire sky, from one edge of the horizon to the other, is a colossal ring. Not a rainbow, not a cloud formation. A ring. Solid, permanent, impossibly beautiful, made of billions of tons of ice and rock, curving overhead like the spine of some ancient cosmic cathedral. It catches the sunlight in ways that make the sky look like it's on fire. It casts shadows across entire continents. And it has been there your entire life, and the life of every human who has ever lived, and every creature that has ever looked upward in wonder or fear. This is not a dream. This is not science fiction. This is a question that scientists, astronomers, geologists, climate researchers, and philosophers have genuinely and seriously asked themselves. And the answers they have uncovered are so stunning, so world-altering, so philosophically overwhelming, that once you hear them, you will never look at the night sky the same way again. What if Earth had rings like Saturn? It sounds simple. It sounds like the kind of idle fantasy you might entertain for a few minutes before moving on with your day. But follow that question even a little way down the rabbit hole, and you will find yourself tumbling through one of the most extraordinary thought experiments in the history of science. Because the implications of Earth having a ring system are not small. They are not minor. They are civilization-altering, ecology-reshaping, mythology-rewriting, physics-defying in their scope. Every single aspect of life on this planet, from the tides that roll across our oceans to the myths that ancient civilizations told around their fires, from the patterns of seasons that govern when crops grow to the way wars have been fought across millennia, every single one of these things would be fundamentally different if our planet wore a ring. And here is the thing that makes this question so genuinely extraordinary, so much more than a simple what if. We are not entirely sure Earth never had rings. There is real scientific evidence, gathered from real telescopes and real geological surveys and real computer simulations run by real researchers at real universities, suggesting that Earth may have had a ring system at some point in its distant past. And there are those who speculate, carefully and with some evidence to support them, that Earth may have rings again in the distant future. This is not fringe science. This is the frontier of planetary science, where some of the sharpest minds in the world are asking questions that challenge everything we thought we knew about the planet we call home. So let us begin. Let us take this question seriously, with all the rigor and all the wonder it deserves. Let us travel back to the beginning of the solar system, to a time before Earth even existed, and understand how ring systems form, why they exist, and why our planet ended up without one. Let us then imagine, in vivid and scientifically grounded detail, what a ringed Earth would look like, feel like, and mean for every living thing on its surface. And along the way, let us ask ourselves the questions that have haunted scientists and dreamers alike. Are we unusual for not having rings? Have we always been without them? And what would it mean for human civilization, for human culture, for human identity, if that band of ice and rock had always been arching overhead? Pause for a moment and ask yourself this. Have you ever looked at a picture of Saturn and felt something? Something almost like longing or awe, or the particular kind of vertigo you get when you stand at the edge of something enormous? Most people have. Saturn is almost universally agreed to be one of the most beautiful objects in the solar system, possibly in the observable universe. There is something about those rings, about their scale and their elegance and their sheer improbability, that touches something deep in the human brain. Now imagine feeling that every single day, every morning when you open the curtains, every night when you step outside. Imagine that being just the sky, just the normal, ordinary sky of the world you were born into. That feeling you just imagined, hold on to it, because we are going to need it. To understand what Earth's rings would look like, feel like, and do to this planet, we first need to understand what rings actually are, where they come from, and why they form where they form. And the story of planetary rings is one of the most fascinating and violent stories in all of astronomy. Rings are not unique to Saturn. That is the first thing to understand. Every giant planet in our solar system has rings. Jupiter has them, though they are faint and dusty, visible only when a spacecraft is looking back toward the Sun. Uranus has them, dark and narrow, so difficult to see from Earth that they were only discovered in 1977, and that discovery was accidental, made when astronomers watching Uranus pass in front of a star noticed the star flickering before and after the planet itself blocked it. Neptune has rings too, 5 of them, with peculiar clumps along their length that are still not fully explained. Even Mars may once have had a ring, and some researchers believe its moon Phobos, which is spiraling slowly inward toward Mars at a rate of about 1.8 centimeters per year, will eventually break apart and form one again in about 70 million years. So rings are not exotic. Rings are not rare. Rings are, in a very real sense, a standard feature of large planetary bodies under certain conditions. The question is always, what are those conditions? And why does Earth not meet them? The material that makes up rings comes from several sources. It can come from moons that have been pulled apart by a planet's tidal forces, which are the same forces that cause our ocean tides but acting on a much larger and more destructive scale. It can come from comets or asteroids that have been captured by a planet's gravity and then broken apart. It can come from the original material of the solar system's formation, primordial debris that never quite coalesced into a moon or a planet and instead settled into orbit around a larger body. And it can come from collisions, from impacts so violent that they shatter a moon or a large asteroid and spread its wreckage across a wide orbital band. The critical boundary that determines whether orbiting material forms a ring or forms a moon is called the Roche limit, named after the French astronomer Édouard Roche, who calculated it in 1848. The Roche limit is the distance from a planet within which tidal forces are strong enough to prevent loose material from clumping together under its own gravity. Inside the Roche limit, any object held together primarily by its own gravity, rather than by its material strength, will be pulled apart by the differential gravitational forces exerted on its near side versus its far side. Outside the Roche limit, gravity can win over those tidal forces, and material can clump together to form moons. Inside the Roche limit, it cannot. Material inside the Roche limit is therefore condemned to remain in pieces, orbiting the planet as rings rather than coalescing into a satellite. Saturn's magnificent rings sit almost entirely within Saturn's Roche limit. This is not a coincidence. This is physics at work. Saturn's rings are between about 7,000 kilometers and 80,000 kilometers above Saturn's cloud tops, and Saturn's Roche limit for water ice, the primary material of its rings, is roughly 87,000 kilometers from the planet's center. So the rings fit neatly inside that boundary, held in perpetual fragmentation by the tidal forces they can never overcome. Now, here is where things get interesting for Earth. Earth has a Roche limit too. For rocky material, Earth's Roche limit sits at about 9,500 kilometers above the surface. For icy material, like the stuff that makes up Saturn's rings, it is a bit different, but still in a similar range. The Moon sits far, far outside this limit, at an average distance of about 384,000 kilometers. This is why the Moon is a moon and not a ring. It formed, or settled into orbit, well outside the zone where tidal forces would have torn it apart. But if the Moon were somehow pushed inside that boundary of 9,500 kilometers, the tidal forces would eventually pull it apart, and the result would be a ring of debris encircling Earth. Take a moment to let that sink in. The difference between Earth having a ring and Earth having a moon is, in a sense, a matter of orbital distance. If something had nudged the Moon, or if the Moon had formed closer to us, or if some other body of similar size had crashed into Earth at an angle that scattered its debris into a lower orbit, we might be living under rings right now. The physics would have allowed it. The physics would have required it. And something like that may actually have happened in Earth's deep past. Scientists studying the geological record have found evidence of unusual patterns in sediment deposition that some researchers believe could be consistent with the existence of a past ring system. A 2024 study published in the journal Earth and Planetary Science Letters, led by researcher Andrew Tompkins at Monash University in Australia, examined the distribution of meteorite impact craters across geological time. What they found was striking. During the Cambrian period, roughly 500 million years ago, there appears to have been an unusual concentration of meteorite impacts clustered near Earth's equator. The standard expectation for random meteorite impacts is that they would be distributed more or less evenly across the globe, with perhaps a slight bias toward lower latitudes because of Earth's spherical geometry. But the Cambrian clustering was far more extreme than chance would predict. The researchers proposed that this could be explained if Earth had a ring system during this period. A ring would deposit material primarily near the equator as it gradually degraded and its particles fell inward, and it would also shield Earth from some impacts at higher latitudes while concentrating impacts at lower latitudes. The ring, in other words, left a fingerprint in the rock. This is an extraordinary claim, and it remains controversial. Other scientists have offered alternative explanations for the Cambrian crater distribution, and the evidence is not conclusive. But the fact that serious planetary scientists at a respected institution looked at this data and concluded that a past ring system is a plausible explanation tells you something important. This is not fantasy. This is science at the frontier, wrestling with real data and real implications. But let us set aside the question of whether Earth once had rings and turn to the more vivid and emotionally compelling question. What would it actually be like if Earth had them now? Close your eyes for a moment, though perhaps keep reading, and imagine you are standing somewhere near the equator. Let us say you are in what we would today call Ecuador, a country that sits almost perfectly on the equatorial line. The sky above you is a deep, brilliant tropical blue, the kind of blue that seems to go on forever. And cutting across that blue, from one side of the sky to the other, is a band. It is not thick, not in the way you might imagine. It is thin, because rings are thin. Saturn's rings, for all their enormous diameter, which stretches to about 282,000 kilometers across, are in most places only about 10 meters to a kilometer thick. If you compressed Saturn and its rings to the size of a football field, the rings would be thinner than a sheet of paper. From the equator of a ringed planet, looking up at rings that are nearly edge-on from your perspective, you would see them as a slashing, glittering line across the sky, a broad stripe of luminous material that catches the sun and scatters light in every direction. And the light would be unlike anything we have ever experienced. Ring material, particularly if it is composed primarily of ice and reflective rock as Saturn's rings are, would reflect sunlight back toward the surface with extraordinary efficiency. Saturn's rings reflect about 60% of the light that hits them. For comparison, Earth's moon reflects only about 12% of sunlight. If Earth had rings with Saturn-like reflectivity, those rings would appear in our sky as something between 5 and 7 times brighter than the full moon. Not the moon. 5 to 7 times brighter than the full moon, as a continuous, permanent feature of the sky. Think about what this means for the night. Ask yourself this question right now, genuinely. What would human civilization have been like if it had never experienced true darkness? Because on a ringed Earth, true darkness as we know it might not exist. The rings would reflect sunlight back to Earth's surface even after the sun had set, functioning like an enormous, permanent reflector orbiting above the atmosphere. The exact brightness would depend on a dozen factors: the composition of the rings, their density, their distance from the surface, the angle at which they are viewed. But under some plausible configurations, the rings could make the night sky so bright that stars would be difficult or impossible to see, especially near the equator where the rings would be most prominent overhead. This is a genuinely staggering thought. Astronomy as we know it might not exist. The ancient Greeks who looked at the night sky and saw the patterns of stars that they named and wrote about and used to navigate and to structure their understanding of the cosmos, they might never have been able to see those stars at all. Or rather, some of them might have, at higher latitudes where the rings arced lower in the sky and blocked less of the stellar view, and in certain seasons when the sun's angle meant the rings were shadowed and therefore dimmer. But the great tradition of stargazing, the thing that gave us Copernicus and Galileo and Newton, The thing that gave us the understanding that Earth orbits the Sun and that the universe is vastly larger than our little planet might have been delayed or even derailed by the brilliant sky that rings would have created. And yet, paradoxically, the rings themselves would have been the most spectacular astronomical object anyone on Earth could ever see. There would have been no need to strain to see something distant and faint when the most overwhelming celestial spectacle in the solar system was right there, overhead, every single day. Ancient humans would have been captivated, awed, terrified, and inspired by those rings in ways that are difficult for us to fully imagine. Every culture on Earth, every mythology, every religion, every philosophical system would have been shaped by their presence. The rings would not have been a discovery, the way we discovered Saturn's rings in 1610 when Galileo first pointed his telescope at the planet and saw something strange on either side that he thought at first might be moons. Earth's rings would have simply been the world, the sky, the given, unquestioned, overwhelming context of all human existence. We will come back to the profound question of what that would have meant for human culture and mythology. But first, let us think about the physics more carefully, because the physics of a ringed Earth are full of surprises, and some of them are genuinely alarming. Where would Earth's rings come from? This is the first question we need to answer, because different origins produce different kinds of rings, and the differences matter enormously. Scientists have proposed several scenarios for how Earth could have ended up with a ring system, and each one tells a different story about what that ring would look like and what it would mean for life on the surface. The most dramatic and the most scientifically well-supported scenario involves the same kind of catastrophic impact that is thought to have formed the Moon itself. About 4.5 billion years ago, in the early violent history of the solar system, a body roughly the size of Mars, which astronomers have named Theia, collided with a young Earth at a glancing angle. The impact was so violent, so incomprehensibly energetic, that it vaporized much of both bodies, sending a vast cloud of debris into orbit around what remained of Earth. Over time, this debris coalesced, just outside the Roche limit, into the Moon we know today. This is the giant impact hypothesis, and it is the currently dominant scientific explanation for the Moon's origin. But here is the thing. The outcome of that collision was not predetermined. It depended on the exact angle and velocity of the impact, the size and composition of Theia, and a dozen other variables. Under slightly different conditions, more material could have been scattered into orbits within Earth's Roche limit, and some or all of it might never have coalesced into a moon. It might have remained as a ring, or the collision might have produced both, a moon outside the Roche limit and a ring of debris inside it. Some computer simulations of the giant impact have actually suggested that early Earth might have had both a ring and the proto-moon, with the ring eventually dissipating over millions of years as its material fell into the atmosphere or was swept up by the growing moon. There is another scenario that is both more recent and more speculative, but no less interesting. Some researchers have proposed that the rings could have come from the tidal disruption of a moon. If one of Earth's moons, early in the solar system's history, had been gradually pushed inward by gravitational interactions with other bodies or by the effects of tidal friction, it could eventually have crossed the Roche limit and been torn apart. The wreckage would have spread into a ring. This is, as we mentioned, exactly what is expected to happen to Mars's moon Phobos in about 70 million years. There is also a scenario in which the rings are not ancient at all, but relatively recent. Astronomers studying Saturn's rings have been shocked to discover that those rings are not as old as Saturn itself. For a long time, it was assumed that Saturn's rings were primordial, dating back to the formation of the solar system 4.6 billion years ago. But data from the Cassini spacecraft, which orbited Saturn from 2004 to 2017 and provided some of the most detailed planetary science data in history, suggests that Saturn's rings are only about 100 to 400 million years old. They are, in geological terms, relatively young. They formed, most likely, when one or more icy moons or comets were torn apart by tidal forces or shattered by a collision. This is astonishing because it means ring systems can be temporary features of planetary systems, coming and going on timescales of tens or hundreds of millions of years. Earth could have had rings in the past that have since dissipated. Earth could form rings in the future if the right conditions are met. And, in a thought that should send a small chill down your spine, the rings are not always stable. Saturn's rings are currently being eroded. Material is raining down into Saturn's upper atmosphere at a rate that NASA scientists have described as dramatic. At the current rate of erosion, Saturn's rings would disappear entirely within about 100 million years, giving them only a few more hundredths of their current lifespan. We are, cosmically speaking, incredibly lucky to be alive at a time when Saturn still has its rings. And this raises a haunting question. When in the history of the solar system was Saturn at its most spectacular, its rings at their thickest and most brilliant? We will never know, because no one was there to see it. But we are here, and we can imagine. So let us imagine. Let us say Earth has a ring system comparable to Saturn's in scale and reflectivity. Let us say it formed about 1 billion years ago from the tidal disruption of a large moon, and it has remained stable since then, a broad, glittering band of ice and rock circling the planet in the equatorial plane. What would it actually look like from the surface? The answer depends enormously on where you are standing. This is one of the most fascinating aspects of a ringed Earth. The rings would look completely different depending on your latitude, and this differential appearance would have created fundamentally different psychological, cultural, and even biological experiences for people living in different parts of the world. Start at the equator. Here, as we mentioned, the rings would appear nearly edge-on. Because the rings are thin, much thinner than they are wide, what you see from directly beneath them is not a broad dome of glittering material but a narrow, brilliant stripe cutting across the sky. Imagine a line of brilliant white or golden light, perhaps 10 degrees wide in the sky, cutting from due east to due west directly overhead. It would be like a permanent, stationary rainbow, but brighter, more defined, more overwhelming. It would divide the sky into two halves, north and south. During the day, it would be clearly visible against the blue sky, though somewhat washed out by the brightness of the sun. At night, it would blaze. It would be the dominant feature of the night sky, outshining everything else by an enormous margin. Now move north or south. As you increase your latitude, the rings begin to tilt in your perspective. They are no longer overhead. They are angled toward one horizon. At 30 degrees north latitude, roughly the latitude of Cairo or Houston or Shanghai, the ring would be a sweeping arc rising from the southern horizon, climbing partway up the sky, and plunging back down to the southern horizon on the other side. It would be like a permanent, glittering rainbow anchored to the south, always there, never moving. The geometry is actually reminiscent of the arc of the Milky Way on a clear night, but vastly brighter and more vivid. At 45 degrees north latitude, roughly the latitude of Minneapolis or Rome or Harbin, the rings would hug the southern horizon more closely, still impressive but no longer dominating the sky. And as you continue north toward the poles, the rings would sink lower and lower until, at the poles themselves, the rings would be essentially on the horizon, a band of light circling the entire horizon like a halo. The poles, interestingly, would be the places most similar to our own sky. From the North or South Pole, the rings would be visible only at the horizon, and much of the night sky directly overhead would be ring-free and dark, giving polar inhabitants a better view of the stars than anyone else on the planet. This is a beautiful irony. The parts of Earth most inhospitable to human life would have the clearest, darkest skies. And here's another question worth pausing over, because it is the kind of question that seems simple but unravels into something profound. What would the rings look like at sunrise and sunset? The answer, according to scientists who have modeled this, is that sunrise and sunset on a ringed Earth would be among the most spectacular sights in the universe. As the sun approached the horizon, its light would begin to catch the ring material at oblique angles, scattering into prismatic cascades of color. The rings are not perfectly uniform. They have gaps, caused by the gravitational influence of small moonlets embedded within them or the resonances created by larger moons orbiting outside them. These gaps would create structure in the light, alternating bands of brightness and shadow sweeping across the sky as the sun's angle changed. Every sunrise and every sunset would be different, a constantly changing light show on an absolutely gigantic scale, produced by the interaction of sunlight with billions of tons of ice crystals in orbit. If you are the kind of person who stops to watch a good sunset now, imagine what it would do to you if every sunset looked like the aurora borealis multiplied by 1,000 and set on fire. But the rings would not just create beautiful lights. They would cast shadows. And the shadows would change everything. Saturn's rings cast enormous shadows on Saturn itself, and Saturn's globe casts enormous shadows on its rings. The interaction of sunlight, planet, and ring creates complex and constantly shifting patterns of light and dark. The same would be true of a ringed Earth, and the implications of those shadows are profound. The most dramatic effect would be on the seasons. Earth's seasons are caused by the tilt of its axis relative to its orbital plane. Earth's axial tilt is about 23.5 degrees, which means that as Earth orbits the Sun over the course of a year, first the northern hemisphere and then the southern hemisphere tilts toward the Sun, receiving more direct sunlight and experiencing summer while the opposite hemisphere experiences winter. This axial tilt is fundamental to Earth's climate, its ecology, its agricultural history. Almost every aspect of human civilization has been shaped by the rhythm of the seasons. Now add a ring in the equatorial plane. The ring is tied to the equator, not to the orbital plane. As Earth tilts on its axis and moves around the Sun, the ring remains aligned with the equator, which means it too tilts relative to the incoming sunlight. During summer in the northern hemisphere, when the North Pole is tilted toward the Sun, the ring would be tilted such that it casts its shadow onto the southern hemisphere. During winter in the northern hemisphere, the shadow would fall on the northern hemisphere. The ring would, in essence, act as a giant parasol that moves between hemispheres with the seasons, blocking sunlight from whoever needs it least while allowing more to whoever needs it most. The climatic effect of this would be complex and, according to climate scientists who have modeled it, likely significant. The rings would reduce the amount of solar energy reaching the surface in the shaded areas, potentially cooling those regions. They might also trap some of the heat radiating up from Earth's surface, depending on the density and composition of the ring material. The overall effect on global temperature is uncertain, but most researchers believe that the rings would moderate Earth's temperatures to some degree, reducing the extremes of both summer heat and winter cold, at least in the regions most heavily shaded by the rings. There would also be an effect on a phenomenon called the solar constant, the total amount of solar energy Earth receives per unit area. If the rings reflected enough sunlight back into space, they could reduce Earth's overall energy budget, potentially making the planet cooler on average. Some models suggest this could be significant enough to make Earth more prone to glaciation, to ice ages. Others suggest the effect might be more modest. The truth is that the exact climate of a ringed Earth is genuinely uncertain and would depend on parameters we would have to specify in considerable detail. But the broad strokes are clear. The rings would change Earth's climate in meaningful ways, and those changes would cascade through the ecology and the history of life on the planet. There is one seasonal effect of the rings that is particularly dramatic, and it relates to something called ring plane crossing. Twice a year, as Earth orbits the Sun passes through the plane of the rings, which means that for a brief period, the Sun is shining edge-on through the rings. At these moments, the rings become nearly transparent to sunlight, because you are looking through their thickness rather than their width. The shadows the rings cast would vanish, and the extra light they had been reflecting back toward Earth would be reduced. These ring plane crossings would cause brief but measurable changes in Earth's climate and light levels, noticeable not just to scientists but to any observant person paying attention to the sky. For ancient peoples without our understanding of orbital mechanics, these moments would be profoundly mysterious. The great ring in the sky would appear to thin and nearly vanish twice a year, and then gradually reassert itself. Such an event would have been irresistible to myth-makers and priests. Speaking of priests, let us step into the world of mythology and culture now, because this is where the question of a ringed Earth becomes almost unbearably rich. Think about how much the night sky has meant to human civilization. Think about Stonehenge, aligned with astronomical precision to the rising sun at the summer solstice. Think about the pyramids of Giza, oriented with uncanny accuracy to true north using stellar observations. Think about the Mayan calendar, one of the most sophisticated timekeeping systems ever devised, built entirely around observations of celestial bodies. Think about the ancient Greek sailors who navigated by the stars, the Aboriginal Australians whose oral traditions encoded astronomical knowledge in stories that preserved observations across tens of thousands of years, the ancient Chinese astronomers who kept meticulous records of celestial events for millennia. All of this astronomical tradition, all of this celestial orientation of human culture, was built around the actual sky that existed. Now change the sky. Add the rings. What happens to human culture? The answer, you will probably realize as soon as you think about it, is that everything changes. In many traditions, the sky is the domain of the gods. The sun is a god, the moon is a god, the stars are gods. What would the rings be? They would be the most prominent, the most dominant, the most inescapable feature of the entire sky. They would make the moon look like a minor player, a secondary character in a drama dominated by that vast, sweeping arc of glittering material. Every religion that has ever existed would have had the rings at its absolute center. The rings would have been the first and greatest fact of divine existence. Consider the cultural implications of a feature of the sky that is permanent but changes its appearance over the course of the year. The rings would be there every day, but they would not look the same every day. The shadows they cast would shift with the seasons. The angle at which they caught the light would change. In the weeks around the ring plane crossings, they would appear to thin and dim. These changes would have been tracked, recorded, and mythologized by every human culture on Earth. In ancient Egypt, for example, the religious and political system was intimately tied to astronomical observation. The annual flooding of the Nile, which was the basis of Egyptian agriculture and civilization, was predicted by observing the heliacal rising of the star Sirius, the moment each year when Sirius first became visible just before dawn after a period of invisibility. The priests who could predict this event had enormous power and prestige. On a ringed Earth, the equivalent priests would have been those who could predict the ring plane crossings, the moments when the great ring in the sky appeared to dissolve and then reform. These would have been the most sacred moments of the year, the times when the gods revealed and then concealed their great work. What myths would the rings have inspired? The possibilities are endlessly fascinating, and while we can never know exactly what stories ancient humans would have told, we can make some educated guesses based on what we know about how mythology works. Mythology tends to personify natural phenomena, to explain them through the actions of beings with human-like motivations. The rising and setting of the sun became the story of a god driving a chariot across the sky. The changing of the seasons became the story of a goddess going underground and returning. The phases of the moon became the story of a lunar deity waxing and waning in power. What would the rings have been? Perhaps they would have been understood as the boundary between the mortal world and the divine realm, a barrier set in the sky to separate humanity from the gods. Perhaps they would have been seen as the prison in which some great cosmic entity was confined, its shimmering presence a reminder of its captivity. Perhaps they would have been understood as the body of a great serpent curled around the world, an image not so different from the Norse mythology of Jormungandr, the Midgard serpent, who encircled the earth with its body. Perhaps, in cultures where the sky was seen as a dome or a bowl placed over the flat earth, the rings would have been the rim of that bowl, the edge of the world. We do not know. We cannot know. But we can be certain that the rings would have been the central organizing myth of every human culture that ever existed, because they would have been the most undeniable, most overwhelming, most visually spectacular fact about the world. And think about this. The rings would have affected not just myths but also practical human activities. Navigation, for example. For most of human history, navigation was done by the stars. Sailors used the positions of stars, and particularly the North Star, Polaris, to determine their latitude and direction. But on a ringed Earth, the stars might be difficult or impossible to see in many parts of the sky, particularly near the bright band of the rings. How would ancient navigators have adapted? Some researchers have speculated that on a ringed Earth, navigation might have been oriented differently. using the rings themselves as a reference. The ring would always be directly overhead for observers on the equator and would always arc from east to west, providing a permanent directional reference. In the absence of clear star navigation, the rings might have been the primary tool for orienting oneself on the surface of the Earth, much as we use the position of the sun during the day. Agriculture, too, would have been profoundly affected. We have already mentioned the climatic effects of the rings, the moderation of temperatures, the potential for increased glaciation, the shifting of shadows across the hemispheres with the seasons. But there would be another, more direct effect on agriculture. The rings would alter the amount and quality of sunlight reaching the surface. In the regions most heavily shadowed by the rings, plant growth might be reduced. In the regions where the rings reflected additional light back to the surface, particularly at high latitudes where the rings might illuminate areas that would otherwise be in polar darkness, plant growth might be enhanced. Some researchers have speculated that on a ringed Earth, the temperate zones might be less productive for agriculture than they are in our world, while areas near the equator might be more productive due to the reflected light from the rings. This would have enormous implications for the history of human civilization. Our actual agricultural revolution began in the Fertile Crescent of the Middle East, and the story of how agriculture spread from there to the rest of the world is one of the central stories of human history. On a ringed Earth, the geography of agricultural productivity would be different, which means the geography of civilization would be different. The empires that rose and fell, the trade routes that connected them, the languages that spread and the ones that died out, all of this would be different. The human history of a ringed Earth is not just different in a few details. It is fundamentally, unrecognizably different from the history we know. But before we lose ourselves entirely in the human story, let us step back and think about the longer, deeper story of life on Earth. Because the rings would have affected not just human civilization, but the entire history of life on this planet, going back billions of years. Life on Earth depends on sunlight. Almost all of the energy that powers the living world comes ultimately from the sun, captured by plants and other photosynthetic organisms and then passed up the food chain. If the rings reduced the amount of sunlight reaching Earth's surface, they would have affected the entire biosphere, the whole system of living things that covers this planet like a thin, miraculous film. The extent of this effect would depend on how much light the rings blocked. A very dense ring, like the inner parts of Saturn's B ring, could block a significant fraction of incoming sunlight. A more transparent ring would have a smaller effect. Scientists who have modeled the climatic impact of hypothetical Earth rings have found a range of outcomes depending on these parameters. Some models suggest a modest temperature reduction of a few degrees Celsius. Others suggest the effect could be larger, potentially enough to push Earth into a glacial state under the right conditions. Ice ages, as it happens, have been some of the most significant events in the history of life on Earth. The most extreme ice ages, which geologists call snowball Earth events, occurred several times in Earth's deep history, most dramatically about 700 million years ago. During a snowball Earth event, ice extended all the way to the equator, covering the entire planet in a frozen shell. The conditions on the surface would have been almost unimaginably harsh, with temperatures far below freezing even at the tropics. Life survived these events, but only barely, huddled around hydrothermal vents and in small liquid water refuges where the ice was thin. Could rings have caused or intensified snowball Earth events? This is a genuinely open question. Some researchers have suggested that the right kind of ring system could have tipped the climate toward a snowball Earth state by reducing the amount of sunlight reaching the surface. Others have noted that the rings might have had the opposite effect in some seasons, by reflecting extra light to the poles during polar winter, potentially warming those regions. The truth is that the climate of a ringed Earth is a genuinely complex system that would require sophisticated modeling to fully understand, and that modeling has not yet been done to a definitive conclusion. What we can say is that the rings would have changed the evolutionary pressures on life, and in ways that would be difficult to predict precisely but profound in their scope. Evolution works by selecting for traits that enhance survival and reproduction in a given environment. Change the environment, even slightly, and you change the selection pressures, And over millions of years, the accumulated changes in the evolutionary trajectory of life become enormous. Think about eyes. The evolution of the eye is one of the most studied and debated topics in evolutionary biology, and it is intimately connected to the light environment that organisms inhabit. Animals that live in well-lit environments tend to have well-developed eyes. Animals that live in dim or dark environments often reduce their eyes over evolutionary time, since maintaining complex eyes is metabolically expensive if they are not needed. On a ringed Earth, where the light environment would be different, particularly at night and in the shaded zones under the ring, the evolution of vision might have followed different paths. Would there be night-adapted creatures uniquely suited to the bright, ring-lit nights? Would there be shadow-adapted creatures evolved to thrive in the cooler, dimmer zones beneath the ring's shadow? The evolutionary possibilities are staggering, and they branch off in 1,000 different directions. We cannot follow all of them here, but we can note that the fundamental principle is the same. Rings change the environment, changed environments change the selection pressures on life, and changed selection pressures change the trajectory of evolution. Now let us think about something that might seem unrelated at first, but turns out to be deeply connected: the tides. Earth's tides are caused primarily by the moon. The moon's gravity pulls on Earth's oceans, creating a bulge of water on the side of Earth closest to the moon and, through a slightly more complex mechanism, another bulge on the far side. As Earth rotates, these bulges sweep around the planet, creating the rhythm of high and low tides that has shaped the ecology of coastlines for billions of years. Many species, both marine and terrestrial, have evolved life cycles synchronized with the tidal rhythm. The spawning of certain fish, the feeding habits of countless shorebirds, the behavior of crabs and clams and sea anemones, all are tied to the tides. Would a ring system create tides? The answer is, almost certainly not significant ones. Tidal forces depend on the mass of the object causing them and, critically, on the distance to that object. Saturn's rings, despite their enormous surface area, contain surprisingly little total mass. The total mass of Saturn's rings is estimated to be roughly equivalent to the mass of the moon Mimas, one of Saturn's smaller moons, or about 100,000th of the mass of our moon. An Earth ring of similar relative mass would exert only trivial tidal forces on Earth's oceans, far too small to create noticeable tides. But here is an interesting wrinkle. If Earth had rings, did it get them instead of, or in addition to, the moon? If the rings formed from the same giant impact that formed the moon, and the ring prevented or depleted the formation of a large moon, then a ringed Earth might have a much smaller moon or no moon at all. And a moonless Earth would have very different tides. Without the moon's tidal forces, Earth's oceans would still have tides, driven by the gravity of the sun, but solar tides are only about half as strong as lunar tides. The tidal range, the difference between high and low tide, would be dramatically reduced. Many coastlines that today experience several meters of tidal range would instead see less than a meter. The intertidal zone, that rich, productive strip of coastline alternately exposed and submerged by the tides, would be narrower and less dramatic. This might seem like a minor detail, but the implications for evolution are significant. The intertidal zone is thought to have been an important nursery for the transition of life from sea to land. The shallow, oxygenated, nutrient-rich conditions of the intertidal environment may have been exactly the conditions that allowed early tetrapods, the ancestors of all land vertebrates including ourselves, to develop the limbs and breathing adaptations that eventually allowed them to colonize the land. A smaller tidal range might mean a narrower intertidal zone and potentially a delayed or altered transition of life onto land. The evolution of land animals, and ultimately of us, might have followed a very different path on a ringier but moonless Earth. The moon also has another profound effect on Earth that is often overlooked. It stabilizes Earth's axial tilt. Earth's current axial tilt of 23.5 degrees is not perfectly constant, but it wobbles only within a relatively narrow range of about 22.1 to 24.5 degrees over a cycle of about 41,000 years. This stability is maintained in part by the moon's gravitational influence, which acts as a kind of gyroscopic damper on Earth's wobble. Without the moon, models suggest that Earth's axial tilt could vary chaotically over a much wider range, perhaps between 0 and 85 degrees, on timescales of tens of millions of years. A 0 tilt would mean no seasons at all. An 85-degree tilt would mean that the poles were alternately pointed directly at the sun, creating extreme seasonal cycles that would make our current seasons look like minor fluctuations. Could life survive on a moonless, ringed Earth with chaotic axial tilt? Probably, since life has shown extraordinary resilience in the face of environmental change. But the life that evolved might be very different from what we see on Earth today, and the conditions for complex, technologically sophisticated civilization might be less favorable. This is one of the most intriguing and debated questions in astrobiology, the study of the conditions for life in the universe. Does a large moon make complex life more likely? Does it stabilize the climate just enough to give evolution the consistent conditions it needs to build complexity? Some researchers think the moon was crucial to the development of intelligent life on Earth. Others think life would have found a way regardless. We cannot answer this question definitively, but we can note that on a ringed Earth where the ring replaced the moon, the question would be asked every day by every philosopher and scientist who looked up at that glittering arc in the sky and wondered what the world might have been without it. But let us not be too pessimistic about the ringed Earth, because while some things would be worse, or at least different in challenging ways, there are aspects of a ringed world that would be genuinely magnificent, genuinely enhancing, genuinely extraordinary in ways that are hard to fully appreciate without thinking carefully about them. Consider, for example, the effect of the rings on art. Human art has always been driven by the world we observe, the landscapes, the faces, the light, the sky. Art is the translation of human experience into enduring form. On a ringed Earth, the most overwhelming visual experience of every human life would be the rings. The rings would dominate painting, sculpture, architecture, poetry, music, every art form that humanity had ever developed. The greatest paintings in the history of a ringed Earth would show those rings in 100 different lights. Dawn rings, sunset rings, rings at night, rings in winter when their shadow fell cold across the northern hemisphere, rings in summer when they blazed against the deep blue sky of the tropics. Think of the great cathedrals of medieval Europe, those astonishing structures built to inspire awe and to orient the human soul toward the divine. The architects of those cathedrals used height, light, and geometry to create an experience of transcendence. They aligned their buildings with the sun, used stained glass to transform ordinary sunlight into something miraculous, soared their spires toward the sky as if trying to reach heaven. On a ringed Earth, architecture would orient itself differently. Cathedrals and temples would be designed to frame the rings, to channel the ring light through their windows, to create spaces in which the relationship between the worshipper below and the great ring above was made tangible and sacred. In the warm, ring-reflecting light of 1,000 different nights, poets would have written about the rings in 1,000 different languages. Scientists would have spent lifetimes studying their composition, their structure, their dynamics. Philosophers would have argued endlessly about what they meant, what they signified about the nature of the cosmos and humanity's place in it. The rings would have been inexhaustible, both as a practical subject of study and as a source of inspiration and wonder. And here is a thought that is both simple and profound. Would a ringed Earth be more likely to inspire early astronomical curiosity, or less? We argued earlier that the brightness of the ring-lit sky might have made it harder to see the stars. But the rings themselves would have been a constant, overwhelming astronomical presence that would have demanded explanation. And the rings change in appearance over time, with the seasons, with latitude, with the angle of the sun. Understanding why the rings look the way they do at different times of year would have required, at a fundamental level, understanding the geometry of Earth's orbit around the sun. In other words, understanding the rings might have driven early astronomers toward the heliocentric model of the solar system even before they had a clear view of the stars. This is a delicious irony. The rings might have made stargazing harder, but they might have made cosmological thinking easier. The rings are a constant, visible demonstration that Earth is a three-dimensional object moving through space. Because the way the ring's appearance changes with latitude and season only makes sense if you understand that Earth is a sphere tilted on its axis orbiting the sun. Every ancient culture living under the rings would have had, in their sky, direct visual evidence of the shape and motion of their world. Contrast this with our actual history, in which the spherical shape of Earth and its motion around the Sun were not widely accepted for most of human history, and were actively resisted by institutions with enormous cultural and political power. The heliocentric model was proposed by Aristarchus of Samos in ancient Greece around 270 BCE, ignored for over 1,000 years, rediscovered by Copernicus in the 16th century, and not fully accepted until the scientific revolution was well underway in the 17th century. Under a ringed sky. It is at least plausible that these ideas would have been understood much earlier, driven by the inescapable evidence of the rings themselves. A world with a different sky might have had a different history of science, potentially a faster one. Now, let us turn to something that might be the most viscerally dramatic aspect of a ringed Earth. What happens when ring material falls inward and hits the atmosphere? This is not a hypothetical concern. It happens right now at Saturn. The Cassini spacecraft measured it directly. Particles from Saturn's rings are constantly falling into Saturn's upper atmosphere in a process called ring rain, and the rate of this rain is surprisingly high. About 10,000 kilograms of ring material falls into Saturn every second. 10,000 kilograms per second. This is not a slow, gentle process. It is a continuous, planet-scale phenomenon. Ring material falling into Earth's atmosphere would not be 10,000 kilograms per second, since that rate is specific to Saturn's current ring dynamics. But some rate of infall would be expected for any ring system, driven by the interaction of ring particles with the planet's magnetic field, the pressure of sunlight, and collisions between ring particles themselves. When this material entered Earth's atmosphere, it would ablate, burning up in the same way that meteors burn up, creating streaks of light. At high enough rates, this would create a permanent, low-level meteor shower visible from the ground, a constant background of shooting stars. At very high rates, it could be more like a continuous light show, with so many particles entering the atmosphere that the sky would be alive with streaks of fire. The actual rate would depend on the specific dynamics of Earth's ring system and is genuinely uncertain. But even a modest enhancement of the meteor rate would be noticeable and would have been intensely significant to ancient peoples for whom shooting stars were already laden with meaning. A sky that regularly rained fire from the ring would be a deeply dramatic and spiritually charged environment. And the occasional larger piece of ring material, a chunk big enough to survive passage through the atmosphere and reach the ground as a meteorite, would bring with it ice and rock from the ring, tangible physical evidence of the great circle overhead. These meteorites would have been among the most sacred objects in any religion practiced under a ringed sky. There is also the question of what ring material would do to Earth's climate over very long timescales. Ring particles falling into the atmosphere would add fine dust to the upper atmosphere. Fine dust in the upper atmosphere reflects sunlight back into space and can cause cooling at the surface. Large volcanic eruptions create similar effects. The 1991 eruption of Mount Pinatubo in the Philippines injected enough sulfur dioxide into the stratosphere to cool global temperatures by about 0.5 degrees Celsius for roughly 2 years. The continuous drizzle of ring material into the atmosphere would have a chronic, low-level version of this effect, potentially contributing to a slight but persistent cooling of Earth's surface over geological timescales. Let us now go further out into space and ask, how would the rings affect Earth's relationship with the rest of the solar system? The rings would create a significant hazard for anything trying to approach Earth from space. Any spacecraft, comet, or asteroid on a collision course with Earth would have to pass through the ring system first, and depending on the density of the ring material, this passage could be dangerous. In the densest parts of Saturn's rings, the concentration of material is high enough that a spacecraft traveling through them would accumulate damage relatively quickly. For Earth's rings, the exact density is unknown, but any significant ring would create at least some risk for incoming objects. This could actually be a protective effect. If Earth's rings were dense enough, they might intercept some fraction of the asteroids and comets that would otherwise hit Earth's surface. Every object that hit the ring instead of the ground would be a mass extinction averted, a civilization-ending impact prevented. The rings would, in this sense, be a planetary shield. Not a perfect one, since the densest ring systems still allow some objects to pass through, but a shield nonetheless. On the other hand, the rings could also create hazards that did not exist without them. Material dislodged from the ring by an external impact, a large comet or asteroid hitting the ring at high velocity, could scatter into new orbits, some of which might intersect Earth's surface. A strike on the ring, rather than preventing impacts on Earth, might in some cases increase them by scattering ring material into Earth-crossing trajectories. This would be a rare event, but over geological timescales, rare events happen. The question of whether Earth's rings would be a net protector or a net danger is genuinely uncertain, and the answer would depend on the specifics of the ring's mass and density, the rate of external bombardment of the solar system, and a host of other variables. But it is a fascinating question, because it shows that the rings are not just a passive decoration on the sky. They are an active participant in the dynamics of the Earth space system, influencing and being influenced by everything around them. Now let us take a moment to think about something that brings this whole discussion into the present day in a very direct and sobering way. Satellites. We currently have thousands of satellites in orbit around Earth. GPS satellites, communication satellites, weather satellites, spy satellites, the International Space Station, the Hubble Space Telescope, and a growing constellation of commercial satellites from companies like SpaceX and Amazon. These satellites are distributed at various altitudes, from low Earth orbit a few hundred kilometers above the surface to geostationary orbit about 35,786 kilometers above the equator. They are essential to modern civilization. GPS alone is woven into virtually every aspect of how we live and move and communicate and fight wars. The global economy depends on satellite communications. Modern weather forecasting depends on weather satellites. Modern military strategy depends on reconnaissance satellites. Now put a ring in Earth's equatorial plane, covering altitudes that include some of the most important orbital zones. The ring would make these orbital zones essentially unusable for satellites. Any satellite attempting to orbit within the ring plane would be immediately bombarded by ring particles traveling at orbital velocities, which are measured in kilometers per second. Even a tiny particle, say, a grain of sand, moving at several kilometers per second relative to a satellite, has enough kinetic energy to cause significant damage. A ring full of such particles would be lethal to any spacecraft trying to orbit within it. This is not a speculative problem. It is the same problem that we are already beginning to face with the growing problem of space debris in Earth orbit. The accumulation of old satellite parts, spent rocket stages, and the debris from satellite collisions in low Earth orbit is creating a hazard for new spacecraft that some scientists worry could eventually make certain orbital zones completely unusable. This scenario, in which a cascade of collisions produces ever more debris, which causes ever more collisions, until an entire orbital zone is filled with a cloud of lethal particles, is called the Kessler syndrome, named after NASA scientist Donald Kessler, who described it in 1978. We are not there yet, but some researchers worry we are moving in that direction. On a ringed Earth, the Kessler syndrome would already be a fact of nature for the ring's orbital zone. Satellites would have to be placed either inside the ring, closer to Earth, or outside the ring, farther away. This would reshape the geography of Earth's orbital space in fundamental ways, constraining where satellites could safely operate and making the exploration of space from a ringed Earth a more complicated and dangerous undertaking. For a primitive technological civilization just beginning to explore space, this would be a major challenge. The first attempts to send objects into orbit would inevitably involve sending them through the ring, and the ring would tear those early spacecraft apart. Developing the technology to safely cross the ring barrier and operate satellites either inside or outside it would be a critical and difficult milestone in the space program of a ringed Earth. It would not be impossible, since we have sent spacecraft through Saturn's rings, most notably the Cassini spacecraft, which executed a series of orbits that took it between Saturn and its innermost ring, in a region called the Grand Finale. But it would require careful planning and robust spacecraft, and it would add a layer of complexity to the already daunting challenge of spaceflight. Of course, on a ringed Earth, the motivation for space exploration might be different in another way. The rings themselves would be an enormously attractive target for exploration. What are they made of? How did they form? Are there moonlets embedded within them? What is it like to fly through them? These questions would be as compelling and as driving for the space program of a ringed Earth as the Moon was for our own space program. The Apollo program was motivated in large part by Cold War politics, but also by the fundamental human desire to stand on the surface of that bright, mysterious object in the sky. On a ringed Earth, the equivalent desire might be the desire to fly into the ring, to understand it from the inside, to touch the ice and rock of the great circle overhead with human hands. The first astronaut to fly into Earth's rings and transmit images back to the surface would be one of the most celebrated humans in history. The images they sent back, of ring particles drifting around them in the silence of space, of Earth's blue surface visible through gaps in the ring material, of the ring stretching away in all directions to the curve of infinity, would be among the most iconic images in human history. They would hang in every schoolroom, inspire generations of children to become scientists and explorers, and serve as a permanent reminder of the extraordinary and improbable world that produced them. Let us pause here and ask another participatory question, one to really sit with. If you knew you were going to live under rings for the rest of your life, what would you want to know most about them? What question would you most desperately want answered? Take a moment. Think about it. Because the answer you give says something about who you are and what matters most to you. For a scientist, the answer might be about composition and origin. For an artist, it might be about beauty and meaning. For a philosopher, it might be about what the rings tell us about the nature of the universe and our place in it. For a child, it might simply be, can I go there? Can I touch them? And the remarkable thing about the rings is that they would make all of these questions feel urgent and personal in a way that abstract astronomical questions never can for us. Our moon is far away and mostly featureless. Saturn's rings are not our rings. But Earth's rings would be our rings, overhead, intimate, personal, as much a part of home as the mountains and the oceans. They would demand answers in a way that nothing in our actual sky ever quite manages. Now let us think about something that is both scientifically fascinating and genuinely haunting. What would happen to the rings over time? Rings are not permanent. We know this from the study of Saturn's rings, which are eroding at a rate that will eliminate them within about 100 million years. Earth's rings, if they existed, would also be subject to erosion by several processes. The Yarkovsky effect, the subtle force exerted by sunlight on a rotating body, would gradually push ring particles out of their orbits. Interactions with Earth's magnetic field would gradually degrade the orbits of charged particles. Collisions between ring particles would gradually redistribute their orbital energy, causing some particles to spiral inward toward Earth and some to spiral outward. Over timescales of millions to billions of years, the rings would change, probably becoming thinner and less dense over time, until eventually they might dissipate entirely or evolve into something quite different from their original form. But there is another, more dramatic possibility. The rings could regenerate. If Earth still had small moonlets embedded within or near the ring, those moonlets would be subject to tidal forces that could gradually push them inward. If a moonlet were eventually pushed inside the Roche limit, it would be torn apart, adding fresh material to the ring and potentially rejuvenating it. This process could repeat, with successive moonlets gradually spiraling inward and being destroyed, keeping the ring system supplied with fresh material for billions of years. Whether this happens in any particular case depends on the orbital dynamics of the moon system and the specific tidal forces involved. Saturn's rings, despite being relatively young in cosmic terms, are thought to have been supplied with material by exactly this kind of process: the gradual inward migration and tidal disruption of moonlets. The same could be true of an Earth ring system. The rings could be old but continuously renewed, like a river that carries away old water while new water flows in to replace it, maintaining an appearance of permanence while constantly changing at the molecular level. There is something deeply philosophical about this image. The rings overhead would appear permanent and eternal to any civilization living beneath them. a fixed and immovable feature of the cosmos, as old as the world itself. But the scientists studying them would know that they are anything but permanent, that every particle in them has its own history, its own journey from the source, and its own eventual fate as it spirals inward and burns up in the atmosphere. The rings would be the most dramatic possible illustration of the paradox of permanence. Things that look eternal are always in the process of change, always transient at some level of analysis. This is a truth that applies to everything, of course, from mountains to galaxies. But the rings would make it visible in real time, if you knew how to look. And there is something both humbling and beautiful about that. Let us now consider the question from a perspective we have not yet fully explored. What would the rings mean for life in space around Earth? Our moon is, among other things, a stepping stone. The moon's relatively weak gravity and its lack of atmosphere make it much easier to land on and launch from than Earth itself. Many proposals for future space exploration have included the moon as a waypoint or a base of operations, a place where you can land relatively easily, extract resources, and launch spacecraft further into the solar system without fighting against Earth's deep gravity well. The moon is also thought to have significant deposits of water ice in permanently shadowed craters at its poles, ice that could be mined and used to produce rocket propellant, making it even more valuable as a space infrastructure asset. On a ringed Earth without a substantial moon, this particular pathway would be unavailable. There would be no convenient nearby world to use as a waypoint. Instead, the rings themselves might serve a somewhat similar function. Ring material, if it is composed in part of water ice as Saturn's rings are, would be a resource that could in principle be mined for water and rocket propellant. The rings would be far easier to access than the surface of any large moon, since they are in orbit around Earth rather than on the surface of a gravitational well. A spacecraft operating within Earth's ring system could potentially scoop up ring material and process it for water, oxygen, and hydrogen propellant, making the rings a kind of diffuse, distributed, self-replenishing resource depot in space. This is, once again, not pure fantasy. The concept of harvesting resources from ring systems has been proposed seriously by space scientists and futurists, and the basic physics of it are sound. Whether it would be practical or economical depends on technological questions that are genuinely open. But the point is that on a ringed Earth, the rings would not just be a visual backdrop. They would be a potential resource, a potential hazard, and a potential destination, all at once. Let us also consider what the rings would mean for the search for life elsewhere in the universe. One of the fundamental questions of modern science is whether Earth-like planets with complex life and civilization are common or rare. The answer to this question has enormous implications for our understanding of our place in the cosmos. If complex life is common, the universe is likely teeming with other civilizations, and our failure to detect any of them is mysterious and alarming. If complex life is rare, we might be alone or nearly alone, and the universe is a vast, mostly empty place of rock and gas and radiation, with this planet as a rare miracle of biology and culture. The existence of rings on other planets is relevant to this question because of how rings form and what they tell us about a planet's history. A planet with rings likely had, or still has, a complex moon system, the product of a dynamic and eventful early history. A planet with a ring formed by the tidal disruption of a moon is a planet that has moons. The presence of moons, particularly large moons like ours, is thought to potentially be important for the stability of climate and axial tilt, which might in turn be important for the development of complex life. If we observe a planet around another star and see that it has a ring system, what should we conclude? Some researchers have suggested that detectable rings around an Earth-sized exoplanet could actually be an indicator of the kind of dynamic, moon-rich planetary system that might be conducive to complex life. Others have argued that very dense rings might be a negative sign, suggesting a recent catastrophic disruption of a moon that might have disrupted the planet's climate and set back the development of life. As with so many questions in astrobiology, the answer is complicated and the evidence is limited. But here is the extraordinary thing. We are actually approaching the point where we might be able to detect rings around exoplanets. The James Webb Space Telescope, launched in December 2021 and now returning some of the most spectacular astronomical data in history, is beginning to characterize the atmospheres and structures of exoplanets with unprecedented precision. Some researchers have proposed that ring systems around exoplanets might be detectable through their effects on the light curves of those planets as they pass in front of their host stars, creating characteristic patterns of dimming that would be different from the pattern caused by the planet alone. If we detect a ring system around an Earth-sized planet in the habitable zone of another star, the implications would be profound. We would know, or at least strongly suspect, that the planet has a dynamic moon system. We might be able to say something about its climate and its habitability, and we would be looking at a world more like what our own world might have been, a planet with a ring overhead, and we would know a little better than we did before what it might be like to live there. This brings us back to the heart of our question, and to something that is genuinely moving if you think about it carefully. The universe is full of worlds we will never visit, and the vast majority of them are as different from Earth as our imagination can stretch. But the question of a ringed Earth is different from the question of a world around a distant star. Because a ringed Earth would still be Earth. It would still be this planet, this blue marble, this small, improbable refuge from the cold and dark of space. It would just be Earth seen differently, Earth under a different sky. And that, perhaps, is why this question resonates so deeply. Because at some level, imagining a ringed Earth is an act of loving attention to the world we actually have. It is a way of seeing Earth fresh, of stripping away the familiarity that makes us take our world for granted and seeing it instead as the astonishing, contingent, and beautiful thing it actually is. We do not have rings. We do not know for certain that we never had them or never will again. But the fact that we might have, the fact that the physics allowed it, the fact that our world could have been so dramatically different and yet still Earth, is a reminder of how extraordinary it is to be here at all. Let us now go deeper into the scientific details, because there is more to explore, and the details are as fascinating as the broad strokes. One of the most interesting questions about Earth's hypothetical ring system is its composition. The composition of the ring would depend on what it was made of, which in turn depends on how it formed. If the ring formed from the tidal disruption of an icy moon, it would likely be composed primarily of water ice, as Saturn's rings are. If it formed from the disruption of a rocky body, it might be composed primarily of silicate rock dust and particles. If it formed from a mixture, the ring would be a complex heterogeneous system with both icy and rocky components. The composition would affect the ring's appearance dramatically. Water ice is highly reflective and would produce a brilliant white or silver ring. Rocky material tends to be darker and less reflective, producing a more somber, reddish-brown appearance. Saturn's rings range from extremely bright in the A and B rings, which are largely water ice, to quite dark in the C ring and the F ring, which contain more dusty material. An Earth ring with a significant rocky component might not have the brilliant white appearance we associate with Saturn's rings. It might instead be a darker, dustier band, still visible but less overwhelmingly brilliant. There is also the question of what the ring's surface chemistry would be. In space, the surfaces of ring particles are constantly bombarded by cosmic rays, ultraviolet radiation from the sun, and particles from the solar wind. These bombardments break chemical bonds and create new ones, gradually modifying the surface chemistry of ring particles over time. Saturn's ring particles have been found to have complex surface chemistry with organic molecules, including some compounds that are also found in biological systems on Earth, forming on their surfaces through purely chemical, non-biological processes. An Earth ring would undergo similar processing over time, developing a complex and scientifically fascinating surface chemistry that would be of enormous interest to chemists and astrobiologists. Would this ring chemistry have any effect on Earth's atmosphere or biology? Probably very little, since the mass of material falling from the rings into the atmosphere is small compared to the overall atmospheric mass. But over billions of years, the cumulative contribution of ring material to Earth's surface could be significant, adding trace quantities of complex organic molecules and mineral dusts to the surface environment. Whether any of this would have a detectable effect on biology is genuinely uncertain, but it is the kind of question that would be intensely studied by scientists on a ringed Earth, who would want to know whether they were in any sense the children of their rings. Now let us think about one of the most evocative and least discussed aspects of a ringed Earth: what it would look like from space. We have an iconic image of Earth from space: the blue marble, the photograph taken by the crew of Apollo 17 in 1972, showing our planet as a luminous blue sphere hanging in the blackness of space. That image has become one of the most reproduced photographs in history, and it has had a profound effect on human culture, helping to fuel the environmental movement and contributing to a shift in how humanity thinks of itself as a species inhabiting a single, fragile, shared world. Now imagine that image with rings. Earth would not look like the blue marble anymore. It would look like nothing we have ever seen or imagined as our home. It would look like a jewel, like something alien, like a planet out of a science fiction film, except that this would be real, this would be home. The rings would catch the sun and blaze with reflected light. Earth's blue surface would be visible through gaps in the ring material, partly obscured by the ring's shadow where the sun was behind the ring, partly illuminated where the sun shone through. The poles would be uncovered, white and bright with ice and snow. The equatorial regions would be alternately shadowed and lit, depending on the season and the angle of the sun. A view of ringed Earth from the moon, if the moon existed, would be one of the most breathtaking sights in the solar system. The rings would be so large relative to Earth that they would dwarf the planet itself, stretching far beyond its equator in both directions, glittering and magnificent. No astronaut who had floated in space and looked back at that ringed Earth could ever quite return to the idea that their world was just another rock in space. It would be undeniably, overwhelmingly magnificent. And what would it look like to alien astronomers, if there are any, looking at our solar system from elsewhere in the galaxy? A ringed Earth would be a much more noticeable planet than the Earth we actually have. The high reflectivity of the rings would make Earth brighter, more conspicuous, more easily detectable by the transit photometry methods that we use to find exoplanets. An Earth-sized planet with a Saturn-like ring would produce a distinctive light curve as it passed in front of the sun, one that alien astronomers with our level of technology could potentially identify as ringed. We would be, in a sense, more visible to the universe. Whether that visibility would be an advantage or a liability in a universe that might contain other civilizations is a question that would have kept many a philosopher on that ringed world awake at night. Now let us think about something that is both deeply practical and deeply philosophical: time. Human beings have always measured time by the sky. The day is the rotation of Earth, the year is its orbit around the sun, the month is approximately the cycle of the moon's phases. These three cycles, the day, the month, and the year, form the backbone of every calendar system humans have ever devised. The specific way cultures have managed the conflicts between these three cycles, since they do not divide evenly into each other, has produced an enormous variety of calendar systems throughout history, from the purely lunar Islamic calendar to the solar Egyptian and Roman calendars to the lunisolar Hebrew and Chinese calendars. On a ringed Earth, time would still be measured by the day and the year. But the month would be gone, or at least diminished, if the ring had formed instead of the moon. And in place of the monthly lunar cycle, there would be a different kind of cycle: the annual cycle of the ring's changing appearance. The ring would not change with a 29-day periodicity like the moon. Instead, it would change with the annual rhythm of Earth's orbit, reaching its most dramatic and most tilted appearance at the solstices, becoming edge-on and appearing thinnest at the equinoxes. Wait, actually, this needs a small correction. The ring plane crossings, the moments when the sun is in the plane of the ring and the ring appears thinnest from Earth's surface, would occur twice a year, near the equinoxes. The ring would appear most tilted and most fully illuminated near the solstices. So there would be a half-year cycle in the ring's appearance, 2 ring plane crossings per year and 2 moments of maximum ring brilliance. This would map onto the seasons in a way that would make the connection between the ring and the rhythm of the year very clear and very salient to any attentive observer. Ancient calendar systems would almost certainly have used these ring plane crossings as calendar markers, the way we use the solstices and equinoxes. The thinning of the ring would be a cosmic signal, as reliable and as dramatic as the phases of the moon, but occurring on a different timescale and carrying different information about the structure of the solar system. And here is something fascinating. On a ringed Earth, The equinoxes would be particularly dramatic events. At the equinoxes, the sun passes through the plane of the ring, meaning that for a brief period, the sun illuminates the ring exactly edge-on. From Earth's surface, this would produce a spectacular display of light effects as the geometry of illumination changed. It would also produce a brief period during which the ring cast no shadow on Earth, because the sun was in the ring plane and therefore not creating a shadow above or below. The transition from ring shadow to no shadow and back again, happening twice a year at the equinoxes, would be a visually striking and astronomically significant event. Ancient priests and astronomers would have marked it with precision, and the culture built around these moments would have been elaborate and deeply meaningful. Consider the religious and cultural weight of an event that occurred twice a year, was visible to everyone on the planet, and involved the literal appearance of the sky changing dramatically in real time. The ring plane crossing would have been the most powerful astronomical event in the life of any ancient civilization, far more dramatic than a solar or lunar eclipse, which are rare and local. The ring plane crossing would be global, annual, and spectacular. It would have been the axis of the calendar year, the moment around which everything else was organized. Let us now take a step back from all these detailed implications and ask the broadest possible version of the question. What would it mean for human identity and self-understanding if we lived under rings? One of the deepest themes in human intellectual history is the question of our relationship to the cosmos. Are we special? Are we at the center of things? Are we the intended inhabitants of a world designed for us? Or are we random accidents in an indifferent universe? These questions have been answered differently by different cultures in different eras, and the answers have had enormous consequences for how those cultures organized themselves and treated the world. The Copernican revolution, the gradual replacement of the geocentric model of the universe with the heliocentric model, was not just a scientific revolution. It was a philosophical and cultural upheaval of the first order. It forced humanity to confront the fact that Earth was not at the center of the cosmos, that the sun, not our planet, was at the center of the solar system, and that the solar system itself was just one of countless planetary systems in the galaxy. Each successive step in this expanding understanding of the cosmos has required humanity to revise its self-image, to become a little smaller and a little more humble in the face of the universe's incomprehensible scale. On a ringed Earth, where would this intellectual journey have started and where would it have led? The rings, as we have argued, would have made it easier to understand Earth's spherical shape and its orbital motion. The heliocentric model might have been arrived at earlier, but the rings would also have given humanity something that we do not have: an undeniable, overwhelmingly visible reminder of the cosmos overhead every single day. We live on a planet that can feel, from the surface, like the whole world. The sky is just the sky, familiar and unremarkable. The stars are distant and faint. The moon is beautiful but small. Nothing in our sky compels us, on a daily, visceral, overwhelming basis, to think cosmologically. On a ringed Earth, the cosmological perspective would be inescapable. The rings would be there every day, every night, in every season, in every culture, on every continent. They would force cosmic thinking on every human being who ever looked up, not as an abstract intellectual exercise, but as an emotional, visceral, daily experience. The universe is large. We are inside it. It is doing things to us, right now, overhead. This might have made the people of a ringed Earth more humble about their place in the cosmos. Or it might have made them more arrogant, more certain of their special status as the inhabitants of the most spectacular planet in the solar system. Or it might have made them more curious, more driven to understand the mechanism behind the Great Ring, more motivated to develop the science and technology needed to go up there and find out what it is. We cannot know. Human nature is complex enough that the same external reality can be used to justify opposite conclusions by different people. But we can say with confidence that the people of a ringed Earth would have been shaped by their sky in ways that we, living under our relatively quiet and unassuming firmament, are not. They would have been cosmological beings in a way that we only become through education and deliberate effort. For them, the cosmos would have been personal. And perhaps that is the most profound insight that this entire thought experiment offers us. We are shaped by the world we live in, but we can use our imagination to see that world as contingent, as one possibility among many, as the product of specific circumstances that could have been otherwise. Imagining a ringed Earth is not just an exercise in planetary science. It is an exercise in perspective. It is a way of holding our own world at arm's length for a moment and seeing it clearly as the particular, accidental, extraordinary thing it is. Our sky, the sky we actually have, with its moon and its stars and its planets and its aurora and its nothing else visible ring system, is not the only possible sky. It is our sky. And maybe, after spending all this time imagining a different one, we can look up at it with a little more wonder. But we are not done. There is more to explore, and some of the most interesting territory is still ahead of us. Let us talk about color. The color of the rings, and what they would do to the color of the light on Earth's surface, is something that most people do not think about, but that would have been one of the most pervasive and inescapable effects of a ring system on daily life. Saturn's rings are not purely white, despite what simplified images sometimes suggest. They have subtle color variations across their width, ranging from a creamy white in the brighter regions to a slightly reddish-brown tint in the dustier areas. These colors come from the specific composition of the ring material. Water ice produces a bright white, while organic compounds and iron oxide dust produce the reddish and brownish tints. The overall visual impression is one of subtle, beautiful complexity, not a single flat color but a tapestry of different shades. Now think about what this ring, hovering above Earth's atmosphere and reflecting sunlight back down, would do to the color of the light reaching the surface. The ring would act as a filter and a reflector, bouncing light of slightly different spectral qualities back toward Earth at different times of day and year. The light reflected from the brighter, icier parts of the ring would be bluish-white and cold. The light from the dustier, redder parts would be warmer in tone. As the sun moved and the ring's illuminated face changed, the quality of the reflected light would shift, creating subtle variations in the color of the ambient light on Earth's surface. At dawn and dusk, when the ring was catching the sun's low-angled light and scattering it through the thickness of the ring, the colors would be particularly complex and beautiful. Artists would chase these light conditions obsessively, trying to capture the quality of ring glow that filled the sky in the minutes before sunrise and after sunset. Photographers, had they existed, would wait for the perfect ring light the way our photographers wait for the golden hour of low sunlight just after dawn or before dusk. There is a concept in photography and painting called the quality of light. The difference between the harsh, direct light of a midday sun and the soft, diffuse light of an overcast day, or the warm, golden light of sunset. On a ringed Earth, there would be an entirely new quality of light, one that has no equivalent in our experience. The ring light of the reflected ring, diffuse and brilliant and colored by the spectral character of the ring material. Every artist who ever lived under those rings would have had access to a visual experience that no human being in our world has ever seen. A quality of illumination that is simultaneously alien and intimate, cosmological and personal. Now let us think about something that bridges science and culture in a particularly interesting way. The naming of things. In our world, the cardinal directions, north, south, east, west, are oriented partly by astronomy. North is toward the North Star. East is where the sun rises. West is where it sets. The direction of gravity defines up and down. These simple orientations are the basis of all human navigation, all cartography, all architecture that tries to align itself with the natural world. On a ringed Earth, there would be a new, overwhelming directional reference. The ring. The ring would always be in the equatorial plane, which means it would always appear to arch toward the equator. From any location in the northern hemisphere, the ring would always arch toward the south. From any location in the southern hemisphere, it would always arch toward the north. The direction of the ring center, directly overhead from the equator and toward the horizon at higher latitudes, would be an additional dimension of orientation that has no equivalent in our world. It seems almost certain that cultures living under the ring would have developed a special orientation terminology that incorporated the ring. Perhaps the ring would have been used to define a two-axis system, the direction toward the ring's center versus away from it. Perhaps the ring would have been used as a vertical reference, the way we use the zenith and nadir to define straight up and straight down. The ring would have added a new spatial dimension to human experience, a new axis of meaning overlaid on the three-dimensional space of the surface world. And this new spatial language would have flowed into metaphor, as all spatial language does. In English, we say things are looking up when they are improving, and going down when they are worsening. We talk about high and low status, of being above or beneath something, of overcoming challenges and falling short. These metaphors come from our spatial experience of a world where up is good and down is bad, because up is toward the sky and the sun and the warmth, while down is toward the earth and the cold and the grave. On a ringed earth, there would be additional spatial metaphors built around the ring. To be in the ring's plane might mean to be at the center of things, at the place of maximum power and visibility. To be under the ring's shadow might be a metaphor for being protected, or suppressed, or hidden, depending on how the culture experienced the ring's shadow, as shelter or as darkness. To pass through the ring, metaphorically, might mean to undergo a transformation, a transition from one state to another. The ring would be inexhaustible as a source of cultural metaphor, because it is inexhaustible as a physical and visual reality. Let us now think about something that is both scientifically interesting and personally moving: the view of Earth from the rings themselves. Imagine for a moment that you are a ring particle. You are a small piece of water ice, perhaps a centimeter across, orbiting Earth in the ring. You move in your orbit at about 8 kilometers per second, completing a full orbit of Earth in perhaps 90 minutes. Earth is below you, a magnificent blue sphere, its surface obscured in places by clouds, its poles gleaming white with ice. The ring stretches around you in all directions, a flat, shimmering disk of particles, each one moving in its own orbit, never quite touching but always nearby. You are tiny. Earth is enormous. The distance from you to Earth's surface is not much greater than the distance from the ground to the edge of space, which is why ring particles, if they could look, would see Earth not as a small disk as the moon appears to us, but as a huge, dominant presence, filling a significant fraction of the sky. Now imagine a human astronaut in that same position, floating in the ring, looking at Earth below, looking at the ring stretching away in all directions. They would see Earth not as we see it from the moon, as a disk about 4 times the diameter of the moon, but as a vast sphere that dominates the view. The ring, stretching away in all directions, would be visible as a flat disk from outside, but from inside, you would see individual particles drifting around you, some catching the sunlight and gleaming like snowflakes, others too small or too dark to see except as a general haziness in the space around you. It would be the most extraordinary environment any human being had ever inhabited. More extreme than the surface of the moon. More alien than the interior of the International Space Station. An environment of perfect silence, extreme cold, and breathtaking visual splendor. The first astronaut to float in Earth's rings and survive would become the most celebrated explorer in human history. Their account of what they saw would be read by every literate person on the planet, and their photographs would define an era. Now let us consider the rings from a different angle, quite literally, by thinking about what they would look like from other planets in the solar system. From Mars, at its closest approach to Earth, the ring system would be visible. Not naked eye, not by any means, but through a good telescope it would be resolvable. Early Martian telescopes, equivalent in capability to our 17th century instruments, would be able to detect the ring as a slight extension of Earth's disk, a mysterious extra width that would puzzle early astronomers. By the time telescopes reached the quality we associate with 19th century astronomy, the ring would be clearly visible, its structure perhaps beginning to be resolved. The discovery, or rather the first clear telescopic resolution, of Earth's ring would be a dramatic astronomical event, even if the ring was already perfectly obvious from Earth's own surface, since seeing it from outside, from another world, would provide a new perspective and new scientific information about its structure and extent. From Jupiter, Earth's ring would be invisible without very large telescopes, since Jupiter can be as far as about 900 million kilometers from Earth. But the existence of Earth's ring would be known, since any civilization on Earth capable of observing other planets would surely have thought about what their own ring looked like from space. From Saturn, Earth would be just another point of light, and its ring would be completely invisible without instruments far beyond anything currently available to us. But from an alien civilization around Alpha Centauri, the nearest star system to our own at about 4.3 light-years away, what would they see? At that distance, even with technology far beyond ours, detecting a ring around an Earth-sized planet would be at the very limit of what is theoretically possible. But it might not be impossible. If the ring were large enough and bright enough, it might be detectable through its effect on the planet's reflected light, creating variations in brightness as the ring's face rotated toward or away from the observer. This kind of detection of a planetary ring from another star system is within the scope of methods that are being developed right now in our world for the James Webb Space Telescope and its successors. The thought that an alien civilization might know of Earth's rings before knowing anything else about our planet, before knowing of life or intelligence or civilization, simply because the rings were the most visible thing about us, is a strangely affecting one. We would be the ringed world. We would be defined, to any observer sufficiently distant to see the whole system, not by our biology or our culture or our history, but by that great circle of ice and rock. We would be, in the view of the universe, a jewelry box world, adorned and glittering. Now, as we approach the final arc of this long exploration, let us think about what happens when the rings end. Because everything ends. We said that Saturn's rings will be gone in about 100 million years. Earth's rings, under various scenarios, might have shorter or longer lifetimes. But eventually, the rings would dissipate. The material would fall into Earth's atmosphere, burn up, and return to the surface as dust. The sky that had been defined by that great arc for millions or billions of years would suddenly, by geological standards, be empty. And any civilization that had evolved under those rings and grown to intelligence during their presence would be faced with a sky that was fundamentally, unmistakably, catastrophically different from the sky they had always known. What would the loss of the rings mean for a civilization that had built its entire culture, its religion, its calendar, its mythology, and its sense of cosmic identity around them? The scale of this cultural loss is difficult to overstate. It would not be like an eclipse, which lasts a few minutes and then is over. It would not be like the appearance of a new star, a nova or a supernova, which is dramatic but temporary. The loss of the rings would be the permanent, irreversible removal of the most dominant feature of the sky, the thing that had been there forever, as long as any story could remember, as long as any geology could record. Of course, the loss would not be instantaneous. It would be gradual, playing out over tens of millions of years, far too slow for any individual or even any civilization to witness in real time. But if we imagine a very long-lived civilization, one that had kept records for tens of millions of years, extraordinary as that sounds, then the progressive thinning and fading of the rings over geological time would be detectable in those records. Ancient texts would describe a ring that was fuller, brighter, more vivid than what later generations saw. Scientific measurements would show a declining mass in the ring system. Astronomers would calculate the timeline to final dissipation and would have to grapple with what that meant. The theological and philosophical implications would be enormous. If the rings were a divine creation, the sign of the gods' presence and care, then their fading would be a sign of divine withdrawal, of something going wrong in the cosmic order. Religious movements would spring up around the fading of the rings, some seeing it as punishment, some as purification, some as the natural completion of a divine cycle that would eventually begin again. Scientists would explain the physics and be largely ignored by those who preferred the theological interpretation, as has always been the case when science challenges cherished beliefs. But for those who could hold both the scientific and the philosophical perspective simultaneously, the fading of the rings would be an invitation to the deepest kind of wisdom. The wisdom that recognizes impermanence at the heart of all things, that sees beauty not despite its transience but because of it. The rings would be beautiful because they were real and because they would not last forever. Their fading would not diminish what they had been. It would complete the arc of their existence, giving it a beginning, a middle, and an end. and perhaps tens of millions of years after the last ring particle had fallen into the atmosphere and the sky was finally empty of the Great Circle. Some species descended from those who had lived under the rings would look up at the clear, star-filled sky, seeing the stars clearly for the first time without the ring's glare, and would marvel at how much was there that they had never been able to see. New stars, new galaxies, new wonders. The end of the rings would be a kind of gift, traded for the gift that had been there all along. There is a theory, and we should be clear that this is speculative, offered in the spirit of intellectual exploration rather than as established science, that the moon itself might someday form a ring. Not for billions of years, and perhaps never, depending on how the orbital dynamics of the Earth-Moon system play out over geological time. The moon is currently slowly moving away from Earth, not toward it, receding at a rate of about 3.8 centimeters per year. This recession is expected to continue for a very long time, not forever, since eventually tidal effects will slow and the moon will begin to approach Earth. But that is so far in the future, if it ever happens, that it is difficult to think about as a real prospect. What is perhaps more interesting and more firmly grounded in science is the question of whether Earth could acquire new rings from other sources. Asteroids are regularly passing through the inner solar system, some of them on orbits that bring them close to Earth. If one of these asteroids were captured by Earth's gravity and placed into an orbit within the Roche limit, it would eventually be torn apart and form a ring. The probability of this happening in any given human lifetime is essentially zero. But on geological timescales, rare events become commonplace. Over hundreds of millions of years, the probability of Earth capturing a ring-forming object increases meaningfully. And there is an even more speculative but genuinely interesting possibility. Could humanity cause Earth to have rings? Not deliberately, at least not as an initial intention, but as a consequence of space activities. The growing problem of space debris, which we mentioned in the context of the Kessler syndrome, is creating an increasingly dense shell of artificial material around Earth in low orbit. If this trend continues for centuries or millennia, the accumulation of debris could become dense enough to be visible from the surface as a dim ring of artificial material, not like Saturn's rings in scale or beauty, but a ring nonetheless. This would be the most unintentional and ironic fulfillment of the ringed Earth thought experiment. We finally get our rings, and they are made of old satellites and rocket stages. But on a more optimistic and more intentional level, some futurists have proposed that humanity might deliberately construct a ring around Earth for various purposes. A ring of solar reflectors, positioned to reflect sunlight away from Earth, has been proposed as a potential method of combating climate change by reducing the amount of solar energy reaching the surface. A ring of solar panels, converting sunlight to energy and transmitting it to Earth's surface, has been proposed as a source of essentially unlimited clean energy. Neither of these proposals is technically feasible with current technology, and both raise serious questions about safety, governance, and unintended consequences. But they show that the idea of a ring around Earth is not just a passive fantasy or a historical contingency. It is an active aspiration, a future possibility that some seriously minded people have considered in detail. We should also address, in the spirit of comprehensive exploration, what the rings would mean for the night side of Earth. We have talked about the ringlit night sky, the way the rings would reflect sunlight back to Earth even after sunset, reducing or eliminating true darkness. But there is another effect, the ring's shadow. During a new moon in our world, the moon is between the Earth and the sun, and the full daylight side of Earth faces the sun with no lunar shadow. The nights of new moon are the darkest nights we experience. On a ringed Earth, the ring would cast a shadow on Earth's surface, and the location of that shadow would depend on the relative positions of Earth, the ring, and the sun. During certain seasons, the ring's shadow would fall on one hemisphere, creating a band of reduced sunlight. At night, parts of Earth that were in the ring's shadow during the day would have experienced less solar heating, and their nights would be cooler. Parts of Earth that were in the ring's reflected light would have been slightly warmer by comparison. This would create a unique and complex temperature distribution on Earth's surface, with bands of relative warmth and relative coolness determined not just by latitude and season, as in our world, but also by the interplay of ring shadow and ring reflection. The meteorology, the weather, of a ringed Earth would be more complex than our own, with additional frontal systems and temperature gradients driven by the ring's interaction with the atmosphere. Weather forecasting on a ringed Earth would be an even more complex science than it is in our world. There is one more aspect of the rings that deserves discussion before we bring this exploration to its close, and it is perhaps the most poetic and most human aspect of all. What would people wish for on a ringed Earth? In our world, people wish on shooting stars, on the first star seen at evening, on eyelashes, on birthday candles. These are small, intimate, hopeful rituals, ways of reaching out to something larger than ourselves and asking for help or luck or love. The star that is wished on is distant, cold, indifferent. But the act of wishing connects us to it, makes the cosmos briefly personal. On a ringed Earth, the wishing star would be the ring itself. Or rather, the pieces of the ring that fell through the atmosphere as shooting stars, which would be more frequent and more dramatic than the shooting stars of our world. When a piece of ring material burned up in the atmosphere, bright enough to be seen across hundreds of miles, it would be a piece of the great sky circle touching the ground, the cosmos reaching down to Earth's surface. To wish on such a thing, to make it a moment of connection between the small human life and the enormous celestial reality, would be deeply, profoundly natural. And every culture on Earth would have done it. Every child who ever lived under those rings and watched a ring streak blaze across the sky would have made a wish. Every poet would have written about it. Every lover would have used it as a metaphor. The ring material, raining down through the centuries and millennia, would have accumulated not just as geological dust on the surface, but as a constant, living metaphor in the hearts and stories of every human being who ever looked up. There is a word in Japanese, mono no aware, that means the bittersweet awareness of the transience of things, the feeling you get when you see cherry blossoms falling and know they are beautiful precisely because they are falling, precisely because they will not last. It is one of the most beautiful concepts I know, a word that captures something that is both universal and difficult to express. On a ringed Earth, mono no aware would be woven into the very sky. The rings would be the most beautiful thing in the world, and anyone who understood the science would know that they were falling, always falling, each particle on its long, slow journey to the ground. The beauty and the impermanence would be inseparable, written in ice and light across the entire sky. Let us take one final scientific detour before we bring this journey to its close, because there is a piece of evidence that is so extraordinary and so recently discovered that it deserves its own moment in our exploration. In 2023, a team of astronomers announced the discovery of a ring system around an asteroid called Quasar, located in the outer solar system beyond Neptune. What made this discovery so remarkable was not just that Quasar, a relatively small body about half the size of Pluto, had rings, but that those rings were located far outside Quasar's Roche limit. According to our understanding of how rings work, material outside the Roche limit should coalesce into a moon, not a ring. And yet there was Quasar's ring, sitting well outside the Roche limit, refusing to coalesce. The discovery shook the scientific understanding of ring dynamics. The researchers concluded that the ring material around Quasar was kept from coalescing not by tidal forces, as in the standard model, but by some other mechanism, possibly the crystalline structure of the ice in the ring, which might make ring particles more elastic and better at bouncing off each other rather than sticking together. This finding suggested that rings can form and be maintained in conditions that were previously thought to be impossible, and it opened up the possibility that ring systems might be more common in the solar system and the universe than we had previously thought. This is significant for our thought experiment because it suggests that Earth might have been able to sustain a ring system even if the material were located somewhat outside the classical Roche limit. The conditions for ring formation may be more varied and more permissive than the classic textbook model suggests. The universe, as always, is more creative and more surprising than our theories. And there is more. In 2014, astronomers discovered that the minor planet Chiron, which orbits the Sun between Saturn and Uranus, appears to have a ring system. And in 2013, the Centaur object Chariklo was found to have two distinct rings, making it the smallest known body with a ring system. Rings are everywhere in the outer solar system, around objects large and small, in configurations that challenge and expand our theoretical understanding. Every new discovery adds to the picture of a solar system in which rings are a common and diverse phenomenon, far more widespread than we imagined just a generation ago. This expanding understanding of rings throughout the solar system makes the question of whether Earth could have had or could someday have a ring seem less like a fantastical hypothetical and more like a sober scientific question. The solar system is full of rings. The mechanisms for forming rings are more various than we knew. The conditions for maintaining rings are more permissive than our classical models suggested. Earth, that small, busy, biologically extraordinary planet in the inner solar system, is the exception rather than the rule in lacking a ring. And exceptions always beg to be explained. Why does Earth not have rings? The question sounds simple, but when you have followed this whole exploration, when you understand how common rings are, how relatively easy they are to form, how diverse their possible origins are, the question gains a new weight. Why does Earth not have rings? The answer seems to be a combination of factors. Earth's proximity to the Sun, which means higher orbital velocities and shorter ring lifetimes in the innermost orbits. The dominant presence of the Moon, which occupies the orbital territory outside the Roche limit and may have swept up ring material early in Earth's history, and perhaps simply luck. The specific details of Earth's early collisional history that sent material into a moon-forming orbit rather than a ring-forming one. These are not deeply mysterious reasons. They are specific, contingent, physical facts about how our particular corner of the solar system developed. But they are reasons that could easily have been different, and the fact that they came out the way they did, giving us the moon instead of a ring, is a historical accident of the most consequential kind. Our moon, our tides, our relatively stable axial tilt, our dark night sky, our ability to see the stars, all of this is the legacy of those specific circumstances 4.5 billion years ago. We have the sky we have because the debris went where it went. There is something wonderful and humbling about that. And as we near the end of our journey, let us zoom out one final time and look at the question from the most cosmic perspective available to us. We live in a universe that is approximately 13.8 billion years old. Our galaxy, the Milky Way, contains between 100 billion and 400 billion stars. A significant fraction of those stars, by some estimates more than half, have planetary systems. Within those planetary systems, there are almost certainly many ringed planets. Saturn is not the only one. We have already found evidence of ring systems around exoplanets in other star systems. As our telescopes improve and our detection methods become more refined, we will find more. The universe is full of ringed worlds. Some of those ringed worlds are in the habitable zones of their stars. Some of them may have liquid water on their surfaces. Some of them may, in the vast statistical lottery of the universe, have life. And some of that life, over hundreds of millions of years of evolution, may have become complex, may have developed intelligence, may have built civilizations. And every single one of those civilizations would have grown up under their rings, would have built their myths and their calendars and their telescopes and their rockets with that ring overhead, would have asked questions about the ring and answered them and asked deeper questions. When we detect these worlds, we will not be able to visit them, at least not with any technology we can currently imagine. The distances are too vast, the journey times too long. But we can watch them, and we can try to understand them. And in understanding them, we will understand something about what it means to be a living thing on a world in a solar system in a galaxy, surrounded by the beautiful and indifferent machinery of the cosmos. Every ringed world out there is a version of a question that was never asked about Earth. Every living thing that looks up from beneath its ring is asking, or not asking, the same question in a different form. What is this? Why is this here? What does it mean that the sky looks like this and not like something else? These are the fundamental questions of intelligence, the questions that take an organism from simply surviving to actually thinking, from mere existence to self-aware existence. We ask them too, from beneath our ringless sky. We look up at the moon and the stars and the thin, faint band of the Milky Way and we ask, what is all of this? Why are we here? Are we alone? These questions are the signature of intelligence, the proof that consciousness has developed to the point where it can turn and look at itself and ask why. A ringed Earth would have asked the same questions, differently framed, differently urgently, differently beautifully. And the fact that we can imagine a ringed Earth, that we can use our intelligence to construct this entire alternative world in such careful and loving detail, is itself a kind of answer. It shows that human intelligence is flexible and imaginative enough to inhabit worlds other than the one it evolved in. It shows that our minds are larger than our experience, that our capacity for understanding extends far beyond what we have directly encountered. We are not ringed. We are not Saturn, not Uranus, not even Quasar. We are a small, warm, biological, beautiful, improbable planet with one large moon and no ring, orbiting an ordinary star in the middle distance of an ordinary galaxy. And that is extraordinary enough. That is more than enough to fill a life of wonder. But every once in a while, it is worth looking up at the sky and imagining what it would be like if that great arc were there. Imagining the way it would transform the night. Imagining the civilizations that might have grown up under it. Imagining the myths and the mathematics and the telescopes and the wishes. Imagining what it would have meant to be human under a different sky. Because imagination is the closest thing we have to a time machine, the closest thing we have to a portal between worlds. And in imagining the rings, we learn something about what we are. Creatures who can see beyond the horizon of their own experience, who can populate the empty sky with wonders, who can love a world they have never seen. The rings are not there. They were perhaps once, long ago, and they may be again, far in the future. But they are there now, in the mind, bright and permanent and impossibly beautiful, arching from horizon to horizon across the sky of an Earth that might have been. And the next time you step outside and look up at the familiar sky, at the moon climbing its old, reliable path, at the stars beginning to appear as the day fades, at the infinite darkness opening above you, take a moment. Take a breath. And ask yourself, what else could this sky have been? What else is this sky right now that I have never quite had the courage or the patience to see? The answers, as always, are in the looking. Let us go deeper still, because there are things we have not yet talked about, things that sit at the intersection of deep time and radical possibility that deserve their proper moment in this exploration. Consider the possibility that Earth's ring, had it existed, would have been visible from pre-human eyes. Long before Homo sapiens walked out of Africa, before Neanderthals hunted the plains of Eurasia, before any hominin stood upright and looked at the sky with anything like comprehension, there were animals on this planet with eyes, with nervous systems capable of visual processing, with brains that could at some level respond to the world above them. Dinosaurs, for example. For roughly 165 million years, dinosaurs were the dominant large land animals on Earth. They had eyes. Some of them, the theropods, many of which were likely intelligent by animal standards, with brains proportionally larger than those of crocodiles or other reptiles, would have had their visual fields dominated by whatever was in the sky. We know that some dinosaurs were highly visual creatures. Certain theropods had forward-facing eyes suggesting good depth perception, and some paleontologists believe that color vision was well developed in the dinosaur lineage, which is supported by the fact that birds, the living descendants of theropods, have extraordinarily good color vision, including sensitivity to ultraviolet light. If there had been rings during the age of dinosaurs, those animals would have seen them, not comprehended them in any philosophical sense, not wondered about them or mythologized them, but experienced them as a constant, overwhelming visual presence. The behavior of dinosaurs might even have been affected by the rings. Ring light at night might have extended the active period of visual predators. The shadow cast by the ring at certain times of day might have created cool spots on the landscape where heat-sensitive animals congregated. The changes in the ring's appearance across the seasons might have been a visual cue, however unconsciously registered, for seasonal behavioral changes. The rings would have been woven into the texture of dinosaur life the way the sun and the rain and the green of vegetation are woven into the texture of all life. And before the dinosaurs, there were other animals looking at the sky. In the Cambrian period, That extraordinary explosion of animal life 540 million years ago, when almost all of the major animal body plans appeared in the fossil record, there were complex animals with sophisticated eyes. Trilobites, those ancient arthropods that lived in the oceans, had eyes made of calcite crystals that may have been among the most sophisticated visual systems in the history of life. What did a trilobite, if it ever looked upward through the water toward the surface, see of the sky above? And if there were rings, would any trace of their light have penetrated deep enough to be relevant to underwater life? Probably not, at least not for most marine life. But for animals near the surface, the quality of light filtering down through the water would have been affected by the ring. The ring's reflection would add to the brightness of the surface waters, potentially affecting the distribution of photosynthetic plankton and the animals that fed on them. Even the underwater world of a ringed Earth would have been subtly different. Let us also think about something more specific and more dramatic. The potential connection between a past Earth ring and one of the most significant events in the history of life, the Cambrian explosion itself. The Cambrian explosion is one of the great mysteries of evolutionary biology. About 540 million years ago, over a geologically brief period of perhaps 20 million years, the fossil record goes from relatively sparse, dominated by simple organisms, to extraordinarily diverse, with representatives of most major animal phyla appearing in an apparent burst of evolutionary creativity. The causes of this explosion are still debated, with proposed explanations ranging from environmental changes such as increases in atmospheric oxygen and changes in ocean chemistry, to ecological dynamics such as the evolution of predation driving an arms race of defensive and offensive adaptations, to developmental innovations that made it easier for animals to evolve new body plans. The Tompkins et al. Study we mentioned earlier, the 2024 study that proposed a past ring system to explain the Cambrian concentration of equatorial meteorite impacts, is interesting in this context because it suggests that if Earth had a ring during the Cambrian, the ring's presence might have had climate effects that could be connected to the environmental changes associated with the Cambrian explosion. A ring reducing solar input to certain latitudes, modifying ocean temperatures and circulation, potentially affecting the distribution of nutrients in the oceans. All of these effects could have been part of the complex set of environmental changes that triggered the Cambrian explosion. This is highly speculative, and the researchers behind the study do not claim to have established a causal link between the ring and the Cambrian explosion. But the possibility is fascinating and not impossible. The rings might not just have been a passive backdrop to the history of life. They might have been an active participant in it, shaping the environmental conditions that drove some of the most important evolutionary events in the planet's history. Let us also consider what the rings would mean for Earth's magnetic field. Earth has a strong magnetic field generated by the convection of molten iron in its outer core, and this field is crucial to life because it deflects the charged particles of the solar wind that would otherwise strip away the atmosphere and bombard the surface with harmful radiation. The magnetic field is one of the reasons Earth is habitable when Mars, which lost its magnetic field billions of years ago, is not. Would rings affect Earth's magnetic field? Directly, probably not significantly. The rings are far too small in mass to have a meaningful gravitational or electromagnetic effect on the dynamics of Earth's core. But the rings would interact with the magnetic field in another way. Charged particles in the solar wind are trapped and directed by Earth's magnetic field, creating the Van Allen radiation belts, two donut-shaped zones of intense radiation surrounding Earth. Ring particles, which are bombarded by the solar wind and can acquire electric charges, would interact with these radiation belts, potentially being accelerated or decelerated, deflected or captured. The interaction between Earth's magnetic field and a ring system would be complex and would take detailed modeling to understand fully. But we know from Saturn that ring magnetosphere interactions are real and significant. The Cassini spacecraft detected electric currents flowing between Saturn's rings and its upper atmosphere, mediated by the magnetic field. These currents were strong enough to affect the chemistry of Saturn's ionosphere. Similar processes on a ringed Earth might subtly affect the chemistry of the upper atmosphere, adding another layer of complexity to the already complex system of interactions between Earth's surface, atmosphere, magnetosphere, and the space environment. Now, let us address a question that is perhaps the most immediately visceral one in this entire discussion. What would happen if a large piece of the ring fell to Earth? We have talked about the steady, slow rain of fine ring particles into the atmosphere. But ring systems are not perfectly smooth and uniform. They contain larger objects, from boulders to small moonlets. These objects, if they were somehow perturbed out of their ring orbits and sent on a trajectory that intersected Earth's atmosphere, would fall to the surface as meteorites or, if large enough, as impactors capable of causing significant local or regional damage. The probability of any given large ring object hitting Earth in any given year would be very small. The ring orbits are stable, and objects in them do not spontaneously fall to Earth. But there are mechanisms by which ring material can be perturbed. Collisions between ring particles can slightly change their orbits. The YORP effect, the rotational acceleration caused by asymmetric radiation pressure on an irregularly shaped body, can gradually modify orbits. And rare but real events like the capture of a comet into the ring system could cause localized disruptions that send material into Earth-crossing orbits. Over millions of years, these rare events would occasionally send larger chunks of ring material into the atmosphere. Most would burn up harmlessly. Some would reach the ground. The impact of a ring-derived meteorite would be geologically indistinguishable from any other meteorite, except that its composition, water ice mixed with mineral dust and organic compounds, would be different from most of the stony and iron meteorites that reach us from the asteroid belt. Ring meteorites would be icy, and they would tend to not survive the passage through the atmosphere intact unless they were very large, since ice ablates readily in the heat of atmospheric entry. For ancient peoples, a meteorite that arrived in a flash of fire and landed on the ground, and that was made of ice, would be profoundly mysterious. It would be a piece of the great ring that had fallen to Earth. It would be a gift from the sky, a sacred object, and as it melted away over hours or days, it would seem to return to nothing, to spirit, leaving behind only a trace of mineral dust. The impermanence of these ice meteorites would make them even more spiritually charged. They came from the sky, they were briefly here, and they were gone, like life itself. There is one final topic we should address before our concluding reflection, and it is one that brings the entire exploration into a more personal and immediate frame. What would it mean, psychologically, to live under rings? Psychology is shaped by the environment. The research literature on this is extensive and robust. Urban environments, natural environments, noisy environments, quiet environments, environments with or without green spaces, all of these have measurable effects on mood, cognition, stress levels, and mental health. The environment we live in is not just a backdrop to our psychological life. It is a participant in it, shaping our thoughts and feelings in ways that are often below conscious awareness. Now imagine an environment in which the most overwhelming visual presence is not the sun or the weather or the landscape, but the ring. A permanent, unchanging, beautiful, and cosmic feature of the sky that is there when you wake up, there when you go to sleep, there in every moment of crisis and joy and boredom and love that you experience. What would that do to the human psyche? Some psychologists have speculated, in the context of the question of what constant access to natural beauty does to human well-being, that environments that regularly expose people to awe-inspiring natural phenomena tend to produce more creative, more empathetic, and more philosophically reflective individuals. Awe, specifically, which is the emotion elicited by encounters with things that are vast and that challenge our existing frameworks for understanding the world, has been shown in experimental research to produce measurable changes in cognition and social behavior. People who experience awe tend to become more curious, more open to new experiences, more willing to revise their beliefs, and more generous toward others. This is not a small effect. Awe is, in some sense, the emotion that makes us better. If this research is correct, then living under rings, with the most awe-inspiring sight in the solar system visible from anywhere on the planet at any time, would produce a population that was chronically, permanently exposed to one of the most powerful psychological influences on human cognition and character. The people of a ringed Earth might, by this logic, be more curious, more open, more generous, more philosophically reflective than the people of our own world. They might be better suited to the kinds of thinking that produce scientific and cultural achievement. They might be more humble in the face of the cosmos and more ambitious in their desire to understand it. Or, alternatively, they might be desensitized. The famous psychological phenomenon of habituation, the tendency of the nervous system to respond less and less to repeated stimuli, might mean that after a few generations, the rings would simply be the background of life, noticed no more than we notice the sky on a clear day.